So this is section 8.6. We're going to review our factoring. It's going to be spread out over two sections, section 8.6 and 8.7. But the first thing to always try and always do when you're factoring is look for a greatest common factor. So if there's a greatest common factor, factor it out. That's the first order of business. So let's do a couple of problems that involve the GCF. We'll start with problem number 22. So this is section 8.6. Problem 22 is 63x cubed y squared plus 81x squared y to the fourth. So when you're looking at these things, you need to determine what they have in common. Now let's start with the numbers, 63 and 81. Is there a number that's in common to both of those? 9. Good. So I'm going to factor out a 9 amongst some other things. Now let's look at some of the variables here. For instance, this has an x cubed and the other one has an x squared. But what's in common to both of those? X squared. So x squared is going to be part of our GCF. What else is going to be part of the GCF? Y squared. So let's think about what's left inside here. If I take out a 9 from this, I'm really dividing that by 9. 9 goes into 63 7 times. How many x's and y's are left from the first term? Good, just one x. Plus, and then we got to repeat this. Again, I'm taking out a 9, an x squared, and a y squared. So what's left when I take that out? Thank you. So 9y squared. Is there any GCF here? Is there anything in common between these two? No, there shouldn't be. Because hopefully we're factoring out the greatest common factor. So if there was something left, then we didn't get everything. You want to get everything as part of your GCF. Let's try another one. Problem number 24. I think I might have modified it a little bit. I don't know. Check it as I write it. So problem 24 is 25x to the 6th minus 10x to the 4th plus 5x squared. Did I make a change from the original problem? Yeah. The reason I did that is because my t's and pluses look so much alike that I don't like to use t's unless I can easily avoid it. So again, two parts of this. First of all, figure out what the GCF is, and then factor it out. So, was it Amanda? What would be the GCF here? What's in common to all of these? 5x squared. Good. So if I take out a 5 here, I'm left with a 5. What about the x? Go ahead. X to the 4th minus 2x to the 2nd oh, I got x to the 4th. All right, we're going to go with the x to the 4th here. That would leave behind a 2x squared. How about the last term? Should I write anything here? Plus 1. Now, that plus 1 is kind of tricky. If I didn't have it there, if all I did was write 5x squared minus 2x, 5x to the 4th minus 2x squared, then when I try and check my problem by distributing, I get this times this, gives me the first one, no problem. This times this gives me the second one, but that's it. I'd only get 2 terms. You need that plus 1 there as a placeholder, so that when you distribute this times this, we get that last term. So that plus 1 is important. I copied this problem down as x to the fourth. So if that's an x to the fourth, then that would be an x squared. If this is an x third, then you're right. That'd be an x to the first. You try one. Problem number 26. In fact, let me give you two. Problem 26 and problem 20. Where is it? 28. So problem 26 looks like this. 18 y squared z cubed. No, y squared z squared. Plus 12 y squared z cubed. Minus 24 y to the fourth z cubed. And then problem number 28 is 14 s cubed plus 15 t to the sixth. What's the GCF for the first one? Six y squared z squared. So that's what you should be factoring out for the first one. Now if I divide that first term by 6, I'm left with a 3. Is there anything else I'm left with? All right. So 3 plus 2, what? Minus 4 y squared z. Is there a greatest common factor in the parenthesis? No. All right. That's good because we should have it all out here. We do. So we're all set for problem 26. How about problem 28? Oh, Bailey?
For the, like when you're factoring it out, like for example for like the 3, since you don't have to add anything, the 3 just stands as the placeholder like 1 would, right?
Yep.
Okay,
Yep.
so I wouldn't have anything else.
Yeah, you don't have to put anything else there. You can check it by distributing. If we did this times 3, I'd get exactly that first term. 18 y squared z squared. And then likewise you can distribute again to the middle term and the third term and get back what we started originally. Nikaya, something look like it's troubling you about this? S. Yep. So what about 28? Is there anything in common there? It's a trap. Yeah, I saw a t-shirt recently, some little girl was wearing it. It says, "Don't grow up, it's a trap." Which I thought was pretty cool. All right, yeah, that one's prime. There's nothing in common between 14 and 15. There's nothing in common between S and T. So that one's prime. And that's it. It's nice. You don't have to worry about anything else on that one. Let's try factoring out -1. So this is convenient sometimes depending on the problem. It's worth practicing a little bit. We'll start with problem 32, minus 6b minus 30. Now it's something that I sometimes show and something that I don't show sometimes. Depends on the class, etc. But when you factor something out, here's what's going on. You're really dividing each term by that factor. I mentioned it up above when we're dividing this by 9, this by 9, this by 6, etc. But if we divide both of these by negative 1, what's going to happen here? What am I going to be left with? Positive numbers, 6b plus 30. Now, I don't want you to show this step here, but you need to tell me what you're going to do in your mind. What's going to be the shortcut to get you from here to here when you factor out a negative? Well, what changed? If you factor out a negative, it's going to change the sign on both of those terms. That's it. That's all that's happening is you're changing the sign. So you can go directly from here to here if you change the signs inside. Yes, ma'am. Mm-hmm. Right? If I distribute, 6 times 2 is the 12. Y squared, z to the second times z to the first. If you add the exponents, 2 and 1 gives me 3. Okay? Right. And conversely, when you're dividing, you subtract. So, like in this one, when I factor out 9x squared y squared, like I said just a moment ago, I'm really dividing each of those terms by what I'm factoring out. So if I wanted to be really formal and careful, I could do this. I could write 63x cubed y squared divided by the GCF, and then 81x squared y to the fourth, again divided by the GCF. And if you subtract exponents, then 3 minus 2 gives me x to the first power. 4 minus 2 gives me y squared. The x squareds cancel. So realistically, this is a step that you're doing. It's just that most of us don't take the time to actually write it down, and you don't have to. If you don't need to, then just jump from here to here. But that's what you're doing, and that gives us a little insight into what's going on here. Dividing by negative 1 is simply going to change the sign on both of those terms. So let's try another one like that. Quick example, and then move on to factoring by grouping. So problem number 38. Let's see. Maybe we want to slow down. We'll do problem 34 and then 38. So we'll do two examples. We've got negative 15y cubed minus 25y squared. Let's look at the instructions for this one. So it says, factor each polynomial by factoring out the opposite of the GCF. So we want to factor out not only the GCF, but the negative of the GCF. So I'm going to factor out a negative, and then I need to look at these terms and figure out what the GCF is. So between 15 and 25, what's common? 5. And how many y's? 5y squared. Now when I factor out that negative, both of these are going to change signs, right? So both of them are going to be positive. In fact, maybe on this one you feel a little more comfortable if I actually wrote it all out. So minus 15y cubed divided by negative 5y squared minus 25y squared divided by negative 5y squared. So that's all the gory details. If you can do that in your head, go ahead. If not, then write it down. But let's see what we get when we simplify this. Minus 5y squared. Lauren, how's this going to simplify? Lauren, you're a ventriloquist. I'm amazed. All right, go ahead. 3y, then what else? positive 5. All right. And that's it. Oh, thank you. How could I check this if I needed to? Distribute. Bailey? Yes. So you can check it by distributing. Good. Let's try another one like that. Problem number 38. So negative 30 x to the 10th y plus 24 x to the 9th y squared minus 60 x to the 8th y squared. This one's long enough that maybe we'll just take a moment separately and figure out what the GCF is. Now the book asks us to factor out a negative along with the GCF. But as far as the GCF is concerned, kind of a divide and conquer approach works nice. Let's do the coefficient part first. What's in common to 30, 24, and 60? 6. So 6 is your GCF amongst those numbers. So I'll have a minus 6. And let's see. Sierra. No, not here today. Let's see. Mackenzie. What's in common amongst the x's? How many x's can I take out? How many do they all have? There's 8 of them here, 9 of them here, 10 of them here, but they all have at least 8. So x to the 8th. How about y's? How many do they all have? Just 1. So minus 6 x to the 8th y. So that's what they all have in common. Now that's the term that needs to get factored out. You're smiling out of place. It's making me nervous. All right. Just a math thing. All right. I got a story I can tell you about that, but I won't tell it on camera. So, in any case, so do you want me to do this step here? Does that help out to divide everything through, or just do it? Let's see if we can't just do it. 6 goes into 35 times. If I'm taking out 8 of those x's, how many are left in the first term? X squared, and I took out the one y. The only y, and I took it. So it's gone. There's no y's left. Now, another thing that you have to be careful about is that all these signs are going to change. So 6 goes into 24 4 times, but because I'm factoring out that negative, it'll be a negative 4. Amila, what's left? Negative 4, x and y. Good. And Colin, want to do the last term? Perfect. Plus 10y. Again, you should look back and make sure that there's no common factors in what you have. There aren't any, so we're good. You can check it by distributing. This times all this will get me back to where I started. Let's move on to factor by grouping. So, Lisa, you were kind of smiling at something, I don't know what, but one thing that comes to mind is I accidentally one time wrote factor by grouping without the u, which became factor by groping, which I don't know, was kind of be an interesting way to factor, though I don't think I'd keep my job very long if I started doing that. All right, so let's work on factor by grouping and see what that's all about. And kind of a mild start to this, almost a GCF here, would be problem number 40. And I'll do my best to make my T's look like something other than pluses. So problem number 40, we've got 4 times x plus y plus, and I hate this. Why did they use a t here? T times x plus y. Okay, well, the way we're going to handle this one is kind of like what we've done with the previous problems. There's a common factor here. Do you see it? What's in common to both of these? X plus y. Good. So x plus y is common to both of these, so I can factor that out. So if I take out the x plus y, what's left behind? 4 plus t. 4 plus t. And that's it. Done. Let's try another one. Let's see which one. Problem number 44. AR minus BR plus AS, and I wonder what the author was thinking when he wrote BS, but whatever. Is there a greatest common factor for the whole problem? No, there's not. So what we're going to do is we're going to set our sights a little bit lower. Let's look at the first two here. Is there something greatest common factor there? R. So Colin, if I factor out the R, what's left behind? A minus B. Good. Let's move over to the second one. Rachel, is there anything I can factor out of the second one? S. So I'll factor out an S. And what's left behind? A minus B. Well, isn't that special, right? These things match. That's good. So you can do a little bit more factorization, right? If you do a little bit more factorization, you're left with A minus B times R plus S. And that's it. Done. Cool. Let's try another one. This is factor by grouping. So this is something you should consider if there's 4 terms. So let's go back to our handout now. This is kind of your guide here. If you have something that has 4 terms, then consider factor by grouping. It's not a guarantee that it's always going to be this, but that's a real good place to start. Let's try problem number 48. B cubed minus 4b squared minus 3b plus 12. So we're asked to factor this. What should be your first step? What should you think of first when you're trying to factor this? Thank you. GCF. Always, always, always look for a GCF. There's not too many times in a math class that I'll actually say always. But when you're factoring, always look for a GCF. Is there a GCF here? Not quite, right? There's no B that's part of the 12 here. So B is not a GCF. So since I've got 4 terms, let's try factor by grouping. So the first term, I can factor out what? B squared. So that's going to leave behind B minus 4. What can I factor out of the second term? Ah, very nice. Now, several of you said minus 3. If you factor out a plus 3, you'd be left with minus B plus 4. And notice that these wouldn't match anymore, which would be a bummer. All right? You need these binomials to be the same. The only difference, though, is that they're opposite in sign. So if I factored out a negative 3 instead, That's going to change the signs on these terms, both of them, and now these match. Yay. So let's finish it up then. Factor out the b minus 4, and what's left? B squared minus 3. Okay. Let's take a look at problem number 50. 50 is a little more challenging. One of the things I want to get across to you in problem 50 is that there's more than one way to do these things. We've got 3c minus cd plus 3d minus c squared. So, is there a GCF for the whole thing? No. But you're always in good shape to look for a GCF. So, if you tried factoring this, you look at the first term, you say, okay, I can factor out a c that leaves behind 3 minus d plus 3d minus c squared. There's nothing in common here. You're like, well, what can I do? Well, one of the things you can do is you can rearrange these. You can write these in different orders. 4 terms, that gives you 24 different orders that you could write it in. So let's see if we can't figure out an order that would make sense. What terms look like they might go together nicely or better? The 3's? All right, so let's write 3c plus 3d. Now what terms haven't I used? Well, I haven't used the minus c squared and the minus cd. So that's a different order. What you should check is that all the signs are the same, right? Positive, positive, negative, and negative. So I didn't change any signs, I just changed the order. So I'm okay there. Did that help me at all? What can I factor out of this one? A 3, right? So C plus D. How about the next one? What can I factor out of that? There we go. Well, I know I'm going to have to factor out a negative because this term here is a positive. Negative what, though? Negative C. If I factor out negative C, Dylan, what's left behind? Good, C plus D. And again, these terms match, which is good. C plus D times 3 minus C. Nice. How could you check it if you're looking back at this and going, you know, I just don't know. I mean, I moved terms around. I'm not sure I got this right. How could you check it? Foil it. Yeah, distribute it, foil it, same thing. So you can check it by just multiplying these two things together. All right, let's move on from factor by grouping. Are you okay with factor by grouping, or you want one more? Yes.
On like our test, is there a certain way you want to see us do it, or were you just showing that to us for like another way to do it?
Well, in this case, you're going to have to move the terms around in some way in order to do this, because the way it was written originally didn't work. So, like I said, there's 24 different ways you could do that. I don't think I want to go through all of them now, because not all of them are going to work. But what I did is I put numbers together or terms together that looked like they went together, like the 3's. And then both of these had a C, so I put those together. So, yeah, some of these are going to work a little bit better than others, but I'm not going to make them really, really complicated. Right? You're not going to have to move terms around too much. let's try factoring trinomials in the nice case. So you've got x squared plus bx plus c. This is the nice case of factoring trinomials. The reason it's the nice case is because in order to factor this, we need to find two numbers that multiply to c and add to b. So when I get a chance, I'll put this factoring strategy on Desire to Learn. So if you want an extra copy or you lose your copy, you can always download one. But we're down here, the nice case. That's section 6.2 if you want to review it there. But we're looking for two numbers that multiply to this and add to this. Let's start with a friendly one, problem number 64. X squared plus 7x plus 6. So I want to factor this. This is going to factor into two things that multiply to 6 and add to 7. Gil, can you think of any two numbers that multiply to 6 and add to 7? It's all right. Two numbers that multiply to 6 and add to 7? You got to think beyond just 2 and 3. What else multiplies to 6? Sending in signals from the sideline. 1 and... There we go. Good job. It's all right. 1 and 6. There you go. Two numbers that multiply to 6 and add to 7. Perfect. Now, sometimes people get a little tongue-tied here and think that they need, negatives. But since all these numbers are positive, all these are going to be positive. And we'll pay attention to the signs of these things as we go through them. Let's move on to problem number 66. So c squared plus 3c minus 28. Now notice in this one, as opposed to the last one, that we've got a minus. So as we factor this, I'll start with a c and a c. One of these has to be plus and one of them has to be minus. Because when I multiply the last two terms together, I get a negative 28. The only way you're going to get a negative is to multiply a positive by a negative. If this term was positive, then both of these terms have to have that sign. Two numbers that multiply to negative 28 and add to 3. 7 and 4 multiply to 28, but which one's going to be the positive, which one's going to be the negative one? Good. The larger one has to have this sign. So c plus 7 times c minus 4. Let me do what I call 66 prime. So this is a little kind of bonus problem for us in this one. What if I had c squared plus 3cd minus 28d squared? Now on the surface of it, it looks a lot harder. You're like, oh wow, we got two variables now. But it's really not much different than problem 66. At least the original problem 66. My first two terms are still going to multiply to a c squared, so I'll have a c and a c. I still need a plus and a minus. The only difference is that I have to multiply these last two terms together and get a d squared. And when I add them, I get a 3cd. So the way to fix that is to just put in a d behind each of these numbers. So 7d and a minus 4d. When you multiply these together, you get the negative 28d squared. When you do the inner products and add them together, you're going to get the 3cd. So just a little heads up, you will see some problems that have that extra variable. Don't worry about it. Just factor them using those numbers, and throw that extra variable at the end here like that. Let's try problem 68. 2y squared plus 4yz minus 48z squared. Norman, you've been kind of quiet. Let me pick on you. What should I do to get started? Perfect. See if there's a GCF. Is there a GCF here? What can I factor out? 2. So that leaves 2 times y squared plus 2yz minus 24z squared. Now, as you continue to factor this, that 2 doesn't disappear. That 2 has to stay out in front. So just leave it out there and be done with it. Now I'll put a y here and a y here. What about the signs that I should put in these parentheses? Plus and a minus. Now I'm looking for two numbers that multiply to negative 24 and add to positive 2. 6 and 4 come to mind right away. Good. Which one's positive? 6. The larger one has to have that sign. So 6 and 4. Am I missing anything?
Yes,
Z. Yeah. Need to put that extra variable at the end. So Z. Okay. Looking good on that one. Certainly this one is made a lot easier by factoring out that 2 to begin with. Let's try problem number 74. So minus 2y squared minus 16 yt plus 40 t squared. I tried as best I could to make my t's look different than pluses with only limited success. Hopefully you can work around that. In case you're stuck, what should be your first step? Good. Factor out the negative 2 as part of your GCF. So factoring out a negative 2 leaves behind y squared plus 8yt minus 20t squared. So what sign should I be using here? One positive, one negative, because this last term is negative, so these have to have opposite signs. Two numbers that multiply to negative 20 and add to positive 8. 10 and 2. The larger one has to have this sign, so positive 10, negative 2. Almost done. T. T. Nice. Okay. There's one last little bit to cover for this section, and that is the not so nice case of trinomials. Ax squared plus bx plus c. So this is the not so nice case. So where we're at is here on our little handout. If there's 3 terms, then you're going to think about factoring a trinomial in a couple different ways. So the first way is the easy case. If the leading coefficient is 1, so meaning the x squared is by itself, so the answer here is yes. And that's what we just did. If the answer here is no, if the leading coefficient is not 1, then you're going to have a little bit more work to do. Now there's a lot of different ways you can factor this. I'm only going to cover one. It's called the AC grouping method. If you can factor these just by looking at them or by some other method that you like and you're comfortable with, stick with it. I like the AC grouping method. It wasn't taught to me when I was a student. I'm mad about that. I think it would have made it a lot easier because I have sympathy for you. I was terrible at factoring these things. Absolutely terrible. At some point later in the semester, I'll share with you how I used to do them. But don't copy this down. Let's do 3x plus 2 times 5x plus 4. Let me multiply these two together and share with you or show you something. So if you FOIL that out, you get 15x squared plus 12x plus 10x plus 8. Or in other words, 15x squared plus 22x plus 8. What I want to point out is what we did for the previous set of problems won't work here. There are no two numbers that multiply to 8 and add to 22. You can search high and low and you won't find them. So the tricks that we used to factor the trinomials in the previous problems simply won't work here. Why not? What's different about this one as opposed to some of our previous ones? Yeah, there's a coefficient of the x squared there. If you have a number that's other than 1 in front of your x squared, you're going to have to do something different. What you choose to do is up to you. But I'm going to suggest that we do what's called the AC grouping method. So to get more practice in this, in your book, you can look back at section 6.3. But the steps here are outlined, and let's follow along with problem number 76. So we've got 5x squared plus 18x plus 9. And I want to factor this thing. Following along our steps, the first thing we're going to do is we're going to multiply the outside numbers. So we're going to do 5 times 9 gives me 45. Once I have the 45, I want to find two numbers that multiply to 45 and add to 18. Find two numbers that multiply to 45 and add to 18. So the 45 is coming from here. Where's the 18 coming from? Right here. All right. Can anyone think of two such numbers? If you can't, one of the things you can do is this. Think of pairs of numbers that multiply to 45 and then add them up. 46, 18. There you go. So two such numbers would be 3 and 15. If you can find those two numbers, you're in good shape. If you can't find those two numbers, then your polynomial is prime. And again, you'd be in good shape. So, how do we do this? We're going to use those two numbers, the 3 and the 15, to break up that middle term. So, instead of an 18x, I'm going to write plus 5x or plus 15x plus 3x. 15 plus 3 gives me 18. So I'm okay there. The rest of this is factor by grouping. What can I factor out of the first pair? 5x. So 5x times x plus 3. And from the second pair, factor out a 3. And finally, I'm all done. Factor out the x plus 3, and you're left with 5x plus 3. That's your final factorization. So it works pretty nice. You don't have to do it that way, but it's a good suggestion. Bailey?
Wouldn't like for the 15x and 3x, wouldn't that have to be like x squared, or wouldn't the x have to be?
What do you mean? 15x plus 3x. When you add those, you would get 18x. It wouldn't give you 18x squared.
I thought it was I'm thinking of like multiplication.
Yeah, you're exactly right. If you're multiplying them, then you would get an x squared term. Okay. Let me give you a couple more like that, and then we'll get you on break. So, any other questions on 76 before I do two more? I don't know. Looking out at you, maybe should I do one more? Maybe you're anxious to get that break. Problem 112. 9x squared plus 6x plus 1. Again, you've got something with a coefficient different than 1 in front of your x squared term. So the first step is to multiply the outside numbers. And it looks kind of undramatic, right? 9 times 9 is, or 9 times 1 is just 9. Well, let's keep working with it. Find two numbers that multiply to 9. What do they have to add to? 6. So find two numbers that multiply to 9 and add to 6. 3 and 3. Alright, so whoops. Should be a 6 here. And then maybe, yeah. I need to color code these a little different. So there. Alright, so 3 and 3. So we're going to take this middle term and split it up into 9x squared plus 3x plus 3x plus 1. So we're splitting that up, but you can see that 3x plus 3x gives me 6x. So we're okay there. Factor by grouping. What comes out of the first pair? 3x. And this is great that we're doing this example because the second part gets a little tricky. What's in common to the second part? What's the greatest common factor? 1. I strongly suggest you put that 1 out there as a placeholder. If you just leave it as 3x plus 1 in parentheses, you might not get the full problem correct when it's all said and done. So if I factor out the 3x plus 1, what's left? 3x plus 1. Now I have one last favor to ask of you. I don't want you to write it like this. What do you think I want instead? 3x plus 1 squared. Definitely. Okay, let's give you a break here. I'll see you in about 8 minutes.